Hello everybody, getting ready to do lesson 9.5 of Pre-Algebra Math, part 1 today. We have a 36-point skill sheet today, and we have no points of note-taking. And today's bell work, teachers, right here, evaluate the expression when A equals 26, B equals 10. Students, and then evaluate, we have, again, the same kind of thing here, and we have this. So give your students 5 minutes. Welcome back, everybody. Here's your solution for number 1. It is 8 by the time you get through your plugins here. 10 squared minus 36, so 100 minus 36, 64. And then down here for number 2, we have square root of 16, which is 4. So that's your bell work for today. Into our lesson today, to find the distance between points A and point B up here. Draw a right triangle. So if you have a situation on a grid, you would draw this line here and then make a right triangle. So you can figure out what the distance is, and then this would be a right angle here. The distance between point A and C is the absolute value of the difference of their x coordinates. Points B and C lie on a vertical line, so B and C, this line here is called vertical. The distance between the points B and C is the absolute value of the difference of their y coordinates. So this would be all vertical, so it would be a difference of their y. This would be the difference of the x values here, because this is horizontal. Okay, classwork page 2. So then the legs of lengths of triangle ABC would be figured this way. AC would be 4 minus a negative 3. This would be 4, then minus a negative 3, which would be 7. So it's 7 units this way. And then BC, which is your vertical line, would be 6 minus 2. They'd be 6 minus 2 would be 4. So there's the lengths of these legs here. Now you can figure what the lengths of the hypotenuse is. It's a hypotenuse use a Pythagorean theorem, so we can plug in now our values into our Pythagorean theorem. Take a positive square root of each side. That's the idea here. So we have 7 squared plus 4 squared will equal our hypotenuse here. So that'd be 65. Square root of 65. 49 plus 16 would be 65. Be the length of that hypotenuse. The distance formula, the distance between 2 points in the coordinate plane is equal to the square root of their sum. So that is another way of looking at distance on the coordinate plane. So in this situation here, distance is x squared minus x1. That would be this here. If we're going to figure this distance all together without doing a triangle here, so we use this formula here to figure the distance of D without doing the whole Pythagorean thing. And then add the vertical squared, so that would be this here, y squared minus y1. This is y1 over here. So, and you put everything underneath the radical like this. You have the difference, then you square it, and then the difference here, then you square it, and then you take the radical of that whole. So let's do that. Find the distance between the points of 6, 3. So 6, 3 and 5, 7. So this would be, see, 5, 7. See, 6, 3. And then 5, 7. I guess this is supposed to be 5, 7 here. And then this would be 6, 3 here. So that's the approximation there. We need to find the distance between these 2 points here. How do we do that? So to do that, we're going to use our distance formula here. We have our 2 coordinates here, so we can plug those values in. 5 minus 6, and square that. And then 7 minus 3, we have that difference and then square that difference. And so what we get is negative 1 squared plus 4 squared, all underneath the radical like that. So we have 1 plus 16. What's that? Square root of 17 would be the distance between these 2 points on a grid, on a coordinate grid. So it'll be square root of 17, whatever that is. So, okay, now let's do this in your guided practice. Students, this is you. So pay attention up here. So find the distance between points. So we have, here's our distance formula, -1, 3, and then 5, 2. So -1, 3 here. Here's your line here is what it would look like on your grid. But we have our coordinates here. We just plug those in to our formula here. We have 5 minus and -1 squared, and then -2 minus 3 squared, and then we have 6 squared. This is 6 squared plus -5 squared. -2, -3 is -5 squared, and then that becomes 36 plus 25, and then that's radical 61, which is something. The distance between points -1, 3 and 5, -2 is radical 61. So that'd be the distance of this line here without going through the hassle of making a rectangle. Okay, now we have a more sophisticated thing here. A bird watcher uses a grid to photograph and record location of birds feeding on the ground. The grid is the location of the bird, how far apart are birds at points A and B. So we have this distance here, and it's on a grid. So the coordinates of the points are 3, 2. This would be 3, 2, and then 7, 5, which is here. So we have our coordinates, so we can figure out what the distance is here. We have our distance formula, and then we just plug in our values into our distance formula. It'd be 7 minus 3, then 5 minus 2. And then we square those differences. And 4 squared plus, what's that? What's 4 squared plus 3 squared? 16 plus 9 square root of 25, it's 5. So the distance between the birds are 5 feet apart. And that'd be the way you can do that. This is your independent practice now. Example 2, how far are the birds apart at points C and D? So we have this point here and then this point way over here. We need to figure out distance is. So here's your line drawn, and then the coordinates are 1, 7, so this is x equals 1, y equals 7, and then when x equals 9, y equals 1, there's your 2 points. So we can plug that in to our distance formula there. So we plug it in, 9 minus 1, 1 minus 7, 8 squared plus -6 squared, what's that? 64 plus 36, what? That's square root of 100, which is 10. So the distance between these two birds would be 10 units. So they're 10 feet apart. That's lesson 9.5 of Pre-Algebra Math, Part 1. You want Part 2, Part 3, email me here. And if you need tutoring or you need quizzes or tests or worksheets or solution PowerPoints, email me here for that request as well. Thank you.